Good morning. Today I am going to discuss two topics named haloalkane and haloarene. As its name suggests, these compounds contain halogen atom in their structural formula or chemical formula. Let's start with the introduction of the topic. Definition of haloalkane and haloarenes can be given by in such a way: hydrocarbon hydrocarbon, whether it may be aliphatic or aromatic. As we know, hydrocarbons may be aliphatic or aromatic. Aliphatic hydrocarbons has open chain or branched chain, while on the other hand, aromatic hydrocarbons has a cyclic chain such as benzene. Let's see an example. Methane, propane, and etc. are the examples of aliphatic, while on the other hand, aromatic may encounter an example of benzene. Let us come on the point. If hydrogen or hydrogen atoms of hydrocarbons, whether it may be aliphatic or aromatic, is displaced by is replaced by any halogen atom, X may be chlorine, bromine, or iodine. If hydrogen or hydrogen atoms of hydrocarbon is replaced by halogen atom, what we get is called haloalkane and haloarene respectively. What does respectively means? Respectively means if hydrogen, one or more hydrogen atom of aliphatic hydrocarbon is replaced by any one of the following halogen atom, what we get is called haloalkane. Haloalkane. While on the other hand, when the hydrogen atom present in aromatic hydrocarbon is replaced by halogen atom, what we get is called haloarene. Haloarene. And these two groups play an important role in organic chemistry. It may be defined in another way. You can see that in haloalkane and haloarene, sp3 hybridized carbon atom, in that case sp3 hybridized carbon atom is directly chemically bonded with halogen atom X. You can see that. You may note that at the carbon atom there is sp3 hybridization, while on the other hand, in the case of haloarene, there is sp2 hybridization on the carbon atom present in benzene ring. The difference lies between the hybridization also. In haloalkane, there is sp3 hybridization on the carbon to which halogen is linked, while on the other hand, in haloarene, halogen atom is directly linked to a carbon which is sp2 hybridized. These two classes plays an important role in industry as well as in day-to-day life, as well as in clinical purposes. In laboratory, haloalkane and haloarene is a good solvent for a non-polar organic compound or weak polar organic compound. So we can say that haloalkane and haloarene are good solvent for weak polar compounds or non-polar compounds. And in clinical purposes, some organic compounds containing halogens atom in it are used as medicines. For an example, chloramphenicol. Chloramphenicol, which is obtained by soil microbes, is used for treatment of typhoid. While on the other hand, chloroquine is used for treatment of malaria. And nowadays, chloroquine is also used to treat COVID-19 viruses, to cure infections caused by COVID virus. Halothane is another haloalkane and haloarene which is used as anesthetics in surgery. Used as an anesthetics in surgery. Finally, it can be concluded that these two groups of organic chemistry, of organic compound, plays an important role in our day-to-day life as well as in industrial purposes. Now, we start classifying it. Classification may be on many bases, one of which is on the number of halogen atom present in it. Now we are discussing about classification. And the first classification of these groups is on the basis of halogen atom present in it. If there is only one halogen atom, these are called monohaloalkane or monohaloarene. If there is two number of halogen atom present in it, these are called dihaloalkane or dihaloarene. And if there is more than two, that is 3 or 4, these are called tri and tetra haloalane or haloarene compounds respectively. For example, CH3Cl chloromethane forms monohaloalkane, while on the other hand, chlorobenzene is an example of monohaloarene. As you can see that there are only one halogen atom present in it. There is only one chlorine atom present in it. And in such a way, CH2Cl2 dichloromethane fall in second category, which is called dihaloalkane, while dichlorobenzene, when there is two chlorine atom present in benzene ring, this is called dichlorobenzene. Monohaloalkane and monohaloarene may be further divided on the basis of hybridization present on the carbon atom to which halogen atom is chemically bonded. Let's see What are these groups? When the monohaloalkane and monohaloarenes are classified further, the first category which we face is monohaloalkane or monohaloarene containing sp3 carbon-X bond. While on the other hand, the second category which falls sp2 hybridized carbon atom -X bond. So monohaloalkane and monohaloarenes may be further divided on the basis of these two type of bonds. Let's start with first one. The first one, monohaloalkane or monohaloarene, which contains sp3 carbon-X bond, may be further divided, and the first one class we face is haloalkane. Haloalkane. In that case, sp3 hybridized carbon is directly linked to the halogen atom. For an example, CH3, Cl, CH3, Br. In that case, you may see that halogen atom is directly linked to a carbon which is sp3 hybridized, and these groups are called haloalkane. This may be further divided on the basis of nature of carbon. The first one category, the second one category, and the third one category, you may note the difference. R, which represents alkyl group. This structure formula is called primary monohaloalkane. When there is only one alkyl group present on the carbon atom to which halogen is chemically bonded. If there is two alkyl group, this one is called secondary. And similarly, monohaloalkane containing three alkyl groups are called tertiary haloalkane. The second one we should discuss about is benzylic haloalkane or haloarene. Haloalkane or haloarene. In that case, halogen atom is directly linked to the carbon which is sp3 hybridized, which in turn is directly linked to a benzene ring. As this example suggests. In that case, you may note that halogen atom is directly linked to a carbon which is sp3 hybridized. On the other hand, this carbon atom is directly linked to a benzene, and this case makes him benzylic haloalkane. And the second one, we get allylic haloalkane. In that case, halogen atom it is directly linked to a sp3 hybridized carbon, which in turn is directly linked to a carbon which is sp2 hybridized. You may note that halogen atom is directly linked to the sp3 hybridized carbon, while on the other hand this carbon is directly linked to a carbon which is sp2 hybridized. This carbon is known as allylic carbon. That is why these haloalkanes are termed as allylic haloalkanes. And the first category of haloalkane or haloarene, which contains sp3 carbon-X bond, may be classified into these three categories A, B and C. In these category, one thing is common is that halogen atom is directly linked to a carbon which is sp3 hybridized. In that case, you may see in that case also, and you may see in that case also. Now, I am going to discuss about another class of haloalkane or haloarene, which contains sp2 carbon dash X bond. And these category may be further divided into two groups. That is, first one is vinylic haloalkane or haloarene. Haloalkane or haloarene. In that case, halogen atom is directly linked to a carbon which is sp2 hybridized, You may note that hybridization on that carbon is sp2 and halogen atom is directly linked to a sp2 hybridized carbon, and this case makes him vinylic haloalkane or haloarene. While the next class which we may get is haloarene. Haloarene may also be termed as if a benzene ring and the carbon present on that ring is chemically bonded to a halogen atom, this class makes him haloarene. In that case, you may see that the carbon present on it is sp2 hybridized and is of benzene ring, and the whole classification may be summarized as we see earlier, haloalkane and haloarene may be divided on the basis of number of halogen atoms, and we find monohaloalkane or haloarene, dihaloalkane or haloarene, and polyhaloalkane or haloarene on the basis of number of halogen atom present in it. Monohaloalkane and monohaloarenes may be further divided on the basis of these two bonds. If there is sp3 carbon dash X bond, we get one category, and if there is sp2 carbon dash X bond, we may find another category. And these are all about introduction of haloalkane and haloarene and classification of haloalkane and haloarene. Let me say something more about it. Haloalkane may also be termed as alkyl halide. Alkyl halide. While on the other hand, haloarene may also be termed as aryl halide. Aryl halide. So there is no need to be confused. Haloalkane may also be termed as aryl halide, and haloarene may also be termed as aryl halide. And that is all about the topic. Thanks.